Hello good day viewers. In this tutorial we are going to find a solution to these two nice trigonometric equations. The first one is sec²x plus tan²x equal to 3, while the second one is cosine 2x equal to sine x. We have a restriction because the value of x has to be from 0 to 360 degrees. Alright, let's get started. Alright, here is our first question. Sec²x plus tan²x equal to 3. Let's start from one famous identity which stated that sin²x plus cosine²x equal to 1, and from here we can divide every single term by cosine x. So you divide this by cosine²x, divide this by cosine²x, divide this by cosine²x. You know that sine divided by cosine is tangent, so we have tangent²x here, plus this is 1, we have 1, and this is what? Secant² x, because 1 divided by cosine is secant. So you can see that secant² is the same thing as tangent²x plus 1. Therefore, we can replace this with tangent²x plus 1. So we have tangent²x plus 1, that is from this one. Then the second one is tangent²x plus tangent²x equal to 3, which is the right hand side, right? So by collecting the like terms, you can see we have tangent², making 2 tangent²x, 2 tangent²x. And you can take 1 to the other side, it becomes negative. 3 minus 1 is 2. So the whole of this is equal to 2. From here, you can divide both sides by 2. You have tangent²x equal to 1. And we can take square root of both sides. You have tangent x to the left equal to plus or minus the square root of 1, which is equal to 1, right? Therefore, tangent x could either be 1 or tangent x equal to negative 1. So where can we find these solutions? Let me draw a unit cycle real quick. Starting from this one, you should know that tangent x is only positive in the first and the third quadrants. And in the first quadrant, we have what? 45 degrees, because tangent of 45 degrees is equal to 1. So this is what we have to do. We draw a straight line here. We have angle 45 degrees here. And what do you think this angle will be? From the standard position down to this leg, it will be what? 180 plus 45. So we have this angle to be 225. So for tangent x equal to 1, we have two solutions. It could either be 45 degrees or 225 degrees. Therefore, from the first one, x equal to 45 degrees and also what? 225 degrees. So what about the second one? Where do we have tangent x to be negative? In the second and the fourth quadrant. So how can we obtain this angle? Remember, initially we got 45 here. So once you subtract 45 from 180, it is going to give you the other angle in the second quadrant. And 180 minus 45 will give us what? 135. Hence, this angle right here is 135. And if you want to get this angle, you add 180 because this is a diameter, right? Add 180 to this, it will give us what? It will give us 315. And you can also subtract 45 from 360. You're still going to get the same thing. Therefore, this particular angle here is 315. And hence, we have two solutions. Either x equal to 135 degrees or 315 degrees. So we have 135 degrees and also 315 degrees. And hence, these are the solutions to this problem, because we are asked to find the solutions between 0 to 360 degrees. So you can always use a unit cycle to find it. But if you don't want to use unit cycle, you should know that tan inverse of 1, because here x equal to tan inverse of 1, and x will be equal to 45 degrees. But you should know that tangent is periodic in every given pi, therefore pi or 180 degrees. Therefore, the other value of x is equal to 180 degrees plus 45 degrees, which is going to give you this one, 225. And if you come to the other one, you take tan inverse of both sides, so you have x equal to tan inverse of -1. If you take tan inverse of -1, you're going to obtain 315 degrees, but 315 degrees is closer to 360. So if you want to obtain the other angle, you can subtract 180 here, and that will give you 135 degrees. So you see we have 4 solutions, 1, 2, 3, 4, which are exactly this one. I obtained this one from unit cycle, while this one from taking tan inverse. So now let us move on to the second question.